As difficult as machine learning is to validate for safety, we have an additional problem that autonomous vehicles have to operate in an incomplete open world in which we do not have all the requirements. There are unusual road obstacles and conditions. Someone decided that taking a retired jet fighter would be pretty cool to have as a car. Well, that's a car, and it doesn't matter whether you expected it or not. If you're behind it on a highway, you have to deal with it. Now, somebody may say, well, I've never seen an aircraft on a road. It can't happen. But I've personally seen that. It turns out if you go to some military bases, there's a stop sign, but you're not stopping for the cars. You're stopping for fighter jets going from the hangars over to the runway, and it's your job to stop and not hit them, because I will assure you, your car insurance does not cover the cost of a brand new F-22. There are other things that are tricky. For example, if you see some water on the road, it's hard to know how deep it is. This human-driven vehicle found out the hard way. I think it's kind of impressive that the headlights are still on, but when you have some standing water, it's really tough. Now, humans have trouble with this too. There's no doubt about that. But if you have no human in the vehicle, the question is, will the autonomous vehicle do at least as well as a human in these kinds of very difficult situations? There are unusual road configurations. Here's a roundabout of roundabouts. There's just the one called the magic roundabout, but if you're driving in that area, your vehicle has to know how to deal with it. There are also strange behaviors. Sometimes there's a person in a chicken suit running around, often selling fried chicken, and you have to correctly categorize that as a pedestrian. It's not okay to hit the giant chicken with your car, even if it doesn't look like a person. And there are often subtle clues. For example, here, there's a person, there's a bicycle. Is that a person in a bicycle completely separate? Well, no, because the hand is intersecting with the handlebars. It looks like the person is holding the bicycle and pushing it. Okay, but is the person on the bicycle riding it, or is the person a pedestrian? And I'm going to say because the feet are flat and both on the ground, it's more likely a pedestrian pushing a bicycle and therefore has to be treated as pedestrian. Why does that matter? Well, the traffic laws are dramatically different, but also the expected thing that happens next is different. If it's a person on a bicycle, they could start moving quite quickly. A person walking next to a bicycle is probably going to have more trouble changing direction, more trouble getting out of the way if there's a bad event, but the person is probably going to move more slowly than someone mounted on a bicycle.